Hello and welcome back to my channel. In this video we're gonna see how do we generate prime numbers in C programming language. So before getting into the video, let us try to look at the constraints required for the coding now. So the constraints required for generating prime numbers are variables, inner and outer looping, header file library, and prime index. So let us go to the compiler and look at what the coding part is and trot the code now. So let us get started with the basic skeleton coding, which starts with hash include studio.h hash include. We are going to include some standard library files in this coding part, and we are going to include the standard boolean header file also, which is going to take in the boolean expressions. Now let us try to see int main where our coding part starts. Now let us initialize the variables int p, int I, and int prime 50 is initially declared to be 0. Now let us try to declare a prime index which is going to skip the even numbers and give us only the required prime numbers. So this skips the even numbers. Now let us declare a boolean expression which is going to be is prime and use it in the coding part. Now let us try to hard code which is going to take index values where my 0th position will be 1. As we are familiar with the Python coding, where we have discussed about the list, where we saw that indexing in the sense means it is going to define the position of the code or a variable where it is going to lie in code specific part of the code. Now let us try to now start with the looping, where my first looping will be the outer looping. So now for p equals to 5, I am taking p equals to 5 because we have already declared the first position to be 0 and the second position to be 3. Now the third position will be from 5. Now I'll say up to 100, where I will say that p will be p plus 2. So for every plus 2 value I'll get my prime number. So 1 plus 2 is 3 and 3 plus 2 is 5. So like that it will be the value for every increment of 2. Now I'll say that is prime equals to true and then just try to implement a 1. Now I'll say that I is equal to p ampersand, which is a logical operator which is going to take care of the true condition. I'll say that prime I is greater than or equal to prime I. So now I'll increment this to plus plus I. Now let us try to declare the if condition also, which will say that p modulus. So after dividing this I by this specific prime numbers, we are going to next code for the remainder which we are gonna get. Prime I will be compared to 0 and now we'll get is prime is equals to false. Let us declare it initially. Now let us try to print the condition if it when it is true. Prime I is equals to true, where I will say that prime of prime index is equals to p. So whatever the value we are going to get in this prime of prime index will be initialized to p. So we have seen here that p equals to 5 and then going to declare for the p value. Now that is the outer looping which is going to take care. I will increment my prime index. Now let us try to do the end coding. Now I equals to 0, I less than prime of I, and I will say that for I every increment. Now I'll say my printf, where I'm going to declare the percentage I, because we want the numbers to be printed in the integers. When it is the case of float, then you need to declare at the stage of variable declaration, where you need to declare, instead of int p, you're gonna take float p. Now let us try to put an end to this code, and now I want for every new line, in order to see it neatly, or else it will be scattered everywhere. Now let us try to end the coding. Now we'll try to debug it. So let us try to debug it. Hopefully there are no errors, and start the decompiler. 1 3 5 7 9 11 13, like that, up to 100 you'll be getting all the prime numbers which are going to lie in this. So this is how you deal with the generation of prime numbers in C programming. So for the source code, you may refer to the description, and if you like this video, do like, share and subscribe to our channel for more interesting content.